What we are starting today is three-dimensional figures. So when you look at this, you're looking at what is the difference between the lateral area and the surface area of a three-dimensional figure. And it's really quite easy. When you look at this, the difference is that the lateral area does not include the bases. Okay, whereas obviously the surface area does. And so in each case, you're going to find the area of your different faces and add them together. The only difference, again, lateral area does not include the bases. Surface area obviously then does include them. So as you guys are looking at this, sorry about that, trying to get my computer woken up this morning. Third time's a charm. Here we go. That does include the bases. Okay, so as you guys look at this, if we look at the three-dimensional figure below, when we're finding the surface area of the following, all that we need to do is find the area of each one of those faces with an F, faces, and then add them together. So let's start with the bases. Now, the way that you know what a base is of a three-dimensional object, especially prisms, is it's the non-rectangular shapes. Let's say that again. Your bases are the non-rectangles. So as you look at this, it should be obvious that in this case, your base is this trapezoid and then the trapezoid directly behind it. So as we look at this, the first thing that we need to do is we need to calculate the area of the trapezoid bases. So your formula for the area of a trapezoid, we've seen it many times before, is 1/2 base 1 plus base 2 times the height. And so as you look at this 18 here will trickle down to this side. So that tells us that the two bases are going to be 18 and 23, and then your height is 12. So when we calculate the area of one of those bases, when you multiply all that out, you get 246 for the area of one of those bases. Now, keep in mind, there's two of them. So we're going to multiply that by 2, and that gets us a value of 492. Again, that represents the area of both bases. Okay. Now, you don't have to worry about labeling that, but that's just to kind of help us keep track as we go. So now what we're going to do is we're going to look at the rectangles that you guys see around your figure. So I'm going to start actually on the left-hand side here. And so if I look here at this particular rectangle, your length and width are going to be 12 and 15. And so when we look at this, you've got 12 by 15, and we'll do all the calculations at the end, okay? This top rectangle is going to be 18 by 15. So we're going to go ahead and write that down, 18 by 15. If we look at this one, we see that 15 again, but we don't know this. So what we can do is we can actually use Pythagorean theorem. So we're going to come back to that one at the end. So I'm just going to go ahead and leave a little gap there. We don't know by 15, just so we can kind of keep that straight. And then the bottom, as we look at that, your bottom is going to be 23 by 15. Okay? So let's take a look at that missing dimension that we don't have yet. So when we look at that, this length here, we can use this right triangle down here to figure out that length. So we know this is 12. This length here will be the difference between the 23 and the 18, which gives us 5. So we can do 5 squared plus 12 squared gives us our unknown squared, and when you solve for that, you get 13. So that is actually this dimension. Okay, so let's go ahead and do our calculations. So when you look at this, we have 12 by 15 gets us 180. You've got 18 by 15 gets us 270. You've got 13 by 15 gets us 195. And then you get 23 by 15, which gets us 345. So all I'm doing is just multiplying those to get our area of each individual rectangle. You can label those to help you if you want as well. So for example, if it helps, you could do that this is the left, this is the top, this is the right, and this is the bottom. And that might help you keep track of things and not accidentally lose something in the process. So then to figure out your total area, all you need to do at the very end is you're going to add everything. So you're going to add all of these numbers here along the right-hand side, and you get a total of 1,482, and your units would be square feet, because again, we're still talking about area. So when you look at this, the other thing to be mindful of, if you look at each of these things here, all right, if you notice, all of them are multiplied by 15. So that is actually the height of the prism. Another way to think of this is that is the difference between the bases, okay? And then these, if I were to add all of these lengths together, what that represents is I look here, I've got, let me go ahead and switch it up, kind of do some erasing here so you can see this. I've got a length of 12, I've got a length of 18, I've got the 13, I've got the 23. So if I look at my original figure, what I just outlined is that's the perimeter of the base. So a quick way to kind of do the lateral area, which is what you see here in this blue bracket, is that the lateral area is equal to the perimeter times the height. Now, do you need to worry about doing that necessarily? No, we just figured out this total here in red without knowing that formula. But if you were to look it up online, there's a strong possibility that they will tell you that the lateral area is the perimeter times the height, or they might actually say that the surface area is the perimeter of the base times the height of the prism plus 2 of the area of the bases. And that's because we have 2 bases that we have up at the top. Again, you have to memorize that. Absolutely not. It's just I wanted to make sure that you guys see that just in case you look it up online. That is actually something that they're most familiar. Okay? So let's take a look at number 8. Excuse me, I said number 8. It's because it's my slide number 8. I apologize. So when we look at this, what we're going to do is we're going to go ahead and figure out your surface area of the entire thing. So what I want for you to do is go ahead and pause your video. Now notice, I just want to go ahead and point out here that in order to figure out your missing side length, you have a side of 8, you have an angle of 28 degrees. So that means that you're going to be doing some trig in there. And what I'm going to have you do is I'm going to have you calculate the total surface area by yourself, put this in your Ed puzzle, and then we'll take some time to talk over it if we need to. If most of you guys get it right, then we'll go ahead and just move on and not worry about it. So take some time to figure this out. Okay, let's take a look at the cylinder. Now what I want for you guys to imagine is that you are going, like think about an oatmeal box or something of that nature. Okay, you obviously have circular bases, so base here and base here. And then you've also got, if you think about the label or a soup can label, if you were to take and cut this down, straight down the side on a soup can and lay it out flat, it is going to form a rectangle. Okay? And so you've got the rectangle of the label of the can or the label of the oatmeal box. And then you've got the 2 circular bases. So obviously the formula for the area of one of those bases is pi r squared. If we look at our picture, the radius is 11, so we know that that is 11. So we can figure out one of those bases by doing pi r squared, which is equal to 121 pi. I'm not going to worry about multiplying that out right now. I don't want to keep track of ugly decimals. So this is 121 pi, and this is 121 pi. Right? Hopefully that's pretty straightforward. Now, the one that's a little bit harder is the rectangle. So again, if you think about laying this flat, this 26 carries over, this is the height of that rectangle, or from the base to base. Now the part that is challenging for most people is, okay, but what is this length? And if you think about that soup can label, if you were to wrap it back around, this, as I go around here, is the length of that rectangle. So when I look at that, that is actually the perimeter or the circumference, which we know is 2 pi r. This is your circumference, 2 pi r. And in this case, 2 pi r is 2 pi times 11, which is 22 pi. And so then when we multiply, because again, it's a rectangle, so 26 times 22 pi is going to get us a value of 572 pi. That is the rectangle in the middle. So your total surface area, as you look at this, is 121 pi plus another 121 pi, those are your 2 bases, plus your lateral area of 572 pi. And if you want to leave it as the exact with that pi in there, you would just add these like they are coefficients. Okay? So you would add 121, 121, and 572. You get 814 pi. That's your exact answer. Nothing has been rounded. If you want an approximation, go ahead and multiply that pi in there. So you get 2,557.26 square yards. Okay, so either one of those, this is the exact, this is the approximate. So again, one of the things just to be mindful of, rectangles, excuse me, cylinders are probably the hardest ones for most people. So one of the things to be mindful of is I kind of put here an in general, just to kind of help you out, that each one of these pieces is A equals pi r squared. Same thing here, A equals pi r squared. And then your rectangle, again, this length here is 2 pi r. This length here is the height of the cylinder. So the area of this rectangle is length times the width. And so that is going to be 2 pi r times your height. So as you look at this, that hopefully kind of makes it a little bit clearer. Again, we're going to go over that triangular prism if we need to. Okay. Other than that, ask questions, especially about the cylinder. The cylinder is traditionally the hardest one for people. So I anticipate that there are going to be some questions there. As always, let me know how I can help. Thanks, guys.